Hey guys, sorry I had to be out today, but here is the kind of how to make sure you know what exactly needs to be on your Vitruvian Man poster. So every single one of you can make 100. So if you were looking at your lab and you need to know what the guiding question is, it's basically printed for you. It says the Vitruvian Man theory states the body is symmetrical. Try to prove this theory by determining whether your height is equal to your wingspan. So your guiding question is going to be something like, is height equal to wingspan? Or is the Vitruvian Man theory correct? Next, you've got your 3 to 5 sentences, your literature review, or your background research. Basically, I told you guys that if you could do this beforehand, it would be a good thing. But if you didn't, that should be 3 to 5 sentences, 3 to 5 bullet points about Vitruvian Man, about Leonardo da Vinci, some background information. You also need your source. If you do not have your source listed, you will not get full credit. All right, next is your hypothesis. Remember, a hypothesis is an if-then statement. You will not include anything about an I or a me or a we or a believe or we think. This is if something is true, then something will equal something else, etc. But it needs to be if and then in that statement. Next is your procedure. This is the easiest part of this. Tell me how your lab group did your experiment. How did you measure each person, etc. Now this one's going to take me a little bit. Now a control is what we call normal. A control is your standard. Okay? It is what a science experiment is supposed to look like. Okay? Next, you've got your constant. What things stayed the same? Did you use the same meter sticks? Did the same person do the measuring? Did you use the whiteboard to make sure it was accurate? Hint, hint, wink, wink. Next is independent and dependent variables. So independent is what you are changing in the experiment. So think about what changed between the measurements that you made. Okay? Then we've got dependent variables. That was what you were actually measuring. So what were you trying to find in this experiment? Next, you've got your data tables. I told y'all yesterday, data table is a fancy word for chart. Literally, you need a chart with everybody in your group. You need their height and their wingspan. If this is not measured in centimeters, you need to go back and redo this. This is science. It needs to be centimeters, and the centimeters need to be included on your chart. Next, you need to draw me a graph. Now, this needs to be a scatter plot graph. If you or someone in your group does not know what a scatter plot is, you need to Google that. Okay? If you drew a bar graph, that's wrong. If you try to do a pie chart, that's wrong. Okay? You need to make sure everybody's name in your group is also labeled in that graph. So, like, if my plotted point was at 155 centimeters and 165 centimeters, it would need to then say Miss Newman next to that dot on that graph. Alright, next you've got a diagram of your lab. This can be as simple or as intricate as you want this to be, but it's a picture of what you did. It can be you measuring each other, whatever you want it to do. If you're an artist, you can draw that to be pretty intricate, but you draw a diagram of what was done in your experiment. Alright, last we've got a conclusion. Now, your conclusion says that you need to sum up what you did. So you need to sum up the planning, you need to sum up the measurements, you need to sum up what you did and why you did it. Now, you also need to tell me why this matters to real life. Why would the body being symmetrical matter? Okay? If you're just writing me 1 to 2 sentences, you need to not. This needs to be a couple of sentences, 3 to 5, and it needs to be intricate and detailed. Alright, you know what you need to do. Good luck. Hope everybody can make 100 on this assignment. We'll talk to y'all on Monday. Have a good weekend. See ya.